We're still going to use the normal CDF. It's just instead of having just a start and a stop, we're going to add the mean and the standard deviation also in there. So our normal CDF will look very similar. Normal CDF. Except for instead of just having the start and stop, we've also got to give the mean and the standard deviation. And again, these two extra pieces of information, the mean and the standard deviation, only need to be given if we don't have z's. We've just got ordinary data. So let's take a look at another example. On this next one, we've got a normal distribution because it says that the lengths of Atlanta croaker fish are normally distributed. So that means we can go ahead and draw our normal curve. And they say that our mean is 10. So I'm going to go ahead and draw that in our middle. Our mean is 10. And let's see, what else did they tell us? They told us that our standard deviation is also 2 inches. So that's our sigma is 2 inches. Find the probability that the length of the fish is less than 7 inches. So we're looking at, we want the probability for less than 7 inches. Probability for less than 7 inches. So continuing along, our 7 is somewhere smaller than our 10 that was in the middle, the mean. And we want less than, which means we want the area to the left. Now, so there's two different things we can do. We can use our traditional normal CDF by converting that 7 into a z-value by taking the value minus the mean and dividing by the standard deviation. Or I can just use our new fancy normal CDF, which would start out by doing the following. If we use the fancy normal CDF, we need our start value first, which remember our graph goes on forever to the right towards negative infinity. Whenever it does that, remember we use negative 10 to the 99th as our starting value because there's no way to use infinity on our calculator, whether it's positive or negative. And then our probability or area we want to stop at the value 7. Now, because 7, we didn't convert it into a z-value, we have to give our 2 extra pieces of information. The first one always has to be the mean, the 10. Our mu has to come first always. Then our standard deviation always has to come second. The sigma, which is 2. And the calculator will do all the heavy lifting in the background. We'll figure out what the probability is by converting the 7 into a z-value. It will do everything for us. So if we plug it into our calculator, let's see what we end up with. Notice using our calculator, what we see is if we plug our normal CDF in, again, remember to get to your normal CDF, you press your second key, then your vars or distribution key, and you arrow down. It tells us that our probability or area is 0.9332. Now, this was just one way to do it. You could have also used our same picture. So doing this a second way. Drawn the same picture with still having the mean in the middle of 10, the mu, and still having our 7, and the fact that we want everything less than that, which means to the left, and writing down our standard deviation because we are going to use that. And what you would do instead, another way to do this would be to turn this 7 into a z-value instead first. Okay, if you were to do that, remember the formula for z-value is to take whatever value you have, subtract the mean, and and divide by the standard deviation. Well, our value we'd be looking at converting is the 7, minus the mean is, well, that's 10. And let's see, divided by the standard deviation, which is 2. Let's see what that gets us. Well, 7 minus 10 divided by 2 is negative 1.5. So that would be your z value. If you take your 7, you'd convert it into a z value of negative 1.5. Now you would still use, just like before for the right hand and when you do your normal CDF, because you're going towards negative infinity, you'd still use a value of negative 10 to the 99th. So now the question is what you would do. You do your normal CDF. And you start out just like before with your negative 10 to the 99th, comma, you'd plug in your negative 1.5 where you ended your graph. And you wouldn't need to input anything else because the negative 1.5 is a z value. You could just close it off. And what your calculator will give you is the exact same value for your probability or area. You'll get still a 0.9332, just like before. So, whether or not you want to do the calculation to find z yourself, or if you're comfortable having the calculator do it for you, it doesn't matter. It's up to you.